So now we are getting into the training process, the actual training process. So let's look at those scripts which we require for training. So like in the last post, again, when we looked into YOLO 5, it came with some native files which would do the training. So similarly with the TensorFlow Object Detection API, we have some native files which are native scripts with which we will do the training. So you can find that those scripts under our root folder models, research, under research, and then object detection. Under this folder you will find a folder called model main tf2.py. So that's the file which is used for training. So what we do is we copy this specific file. We copy the specific file from this folder and then keep it in our root folder under a workspace. Since our training is happening in our workspace, we'll copy those same file inside our workspace under the training pothole folder. So we will keep it here, and let's look at the command line for the training. So this is the command line for the training. So first you give obviously the Python, then the name of the file, which is that model main main tf2.py, and then we give the model directory. Now this model directory is the models, my models which we created. So models and my SSD ResNet 50, that's what we've give us our model directory, because that's where the training is going to happen and where the checkpoints would be generated. And then we also give the path to the config file. So again, it is we know that we have made those changes for this config file, so we give the path to this config file. So and then we execute this. Once we run this, the training process will go on. Now a word of caution, a note of caution is this training process is a very time consuming one, and it takes a lot of time depending on your capacity of your machine. So it might take a lot of time, and there could be some instances where you feel that, okay, this has it got is it hanging or is it hung up? But don't worry, it is not hung up, because you will not find any output for quite some time, because after the initial output, so like say for example, it'll kind of stop here, and then it will stop there for quite some time, and any outputs are generated only after every 100 steps. So after 100 steps you will find something like this, these lost files, and every 100 steps you will get those these outputs. So here I have configured for 400 steps, and that's why every 100 steps you will see all these the outputs are getting generated. So even if you feel that whether it is hung up or it's not doing anything, it's actually doing something, because, and this is a very slow process. Another thing which you can also do is you can also try to visualize those training steps in a tensor board. So here under the training pothole, under the folder, you just give tensor board, and the log directory is models my SSD ResNet. So under this you will find under the train. So once the training starts, you will find a folder like this, a train folder, and these events are logged here. So this is what is required for you to visualize in tensor board. So once the training starts, you will find all these checkpoints which are created. So for each training you will find a checkpoint with a specific number. So here I have done two training steps. Twice I have done training, so that's why you will find checkpoint 1 and checkpoint 2. So if you look at the checkpoint file, it will give you the last the latest path which you will have to take, which is checkpoint 2, and the timestamp for this thing. Now you'll see the timestamp as a very odd one, because this is a Unix format. Now if you want to see the real what is the actual date, then you just need to copy it, and then there's this unique timestamp converter. Okay, so this unique timestamp converter is there. You just search in Google what the unique timestamp converter. So you give that number and then give the timestamp. So and then you'll find that specific path there. So that's the last result. Let me copy this. This is for today. Let me copy it here, and then so I'm running it on August 5th 2022 today. So this is the file. So that's the timestamp, latest timestamp for the latest model run which I have got. So you'll find all this all these things getting generated once the training process starts. So it's going to take a long time, and then you will find all those files. So once the training is done, then what we will do is we will take the best model, the checkpointed models, and then export it for our inference process. So that's what we will do. We will see next in the next video. We'll see how we will take the trained model and then use it for our inference. Now, after our training process, we'll find our checkpointed models inside our folder, the training folders. What we need to do is now we have to export the best model from here into a folder called the exported models. So we have created this exported models before, and then we have to export the best model from here, and so our inference would be running from this exported models folder. So there is another file for this, another script which you will find again inside models research object detection, and this model file, the file name is exporter main v2.py. So this is the file. So we have to copy this file and from the models file here, and then keep it under our workspace, because everything is going to happen in our workspace, and therefore you'll have to keep it under training pothole. You have to keep the exporter main v2.py. So it's a long file which necessarily what it does is it looks at the checkpoint information of our models which have been run, and it copies the best model into this exported model. So let's look at it's again a single command line. I'll show you that command line in the Jupyter notebook, but it has to be executed here in the terminal here. So please remember that command line has to be executed here in the terminal, but for just demonstration purpose, I'm just showing it in the Jupyter notebook. So obviously the first is Python, then the file name exporter main.py, and you are giving the input type which is an image tensor. So that's a standard one which we have to give because it's a tensor image which we're going to give. And here is the pipeline config path. So we remember that the config pipeline, the config path which we altered. So we have to give the path for that. So that's models mySSD.fpn, this one. So you can see it here, models mySSD dot this file is what we give here, pipeline.config, and then we give the train checkpoint directory. So that's again models mySSD.fpn. So this is the my models mySSD. This path is what we give. This is because this is where we have the checkpoints. So we give the path here, and then we also specify what is the output directory where my models have to be created. So here we know that it's the exported models. Now this is a specific name which we give for each of our models, each type of model runs which we have. So so inside exported models, I've created this folder called the my model. So it should copy here. So once you execute this, not here in the Jupyter notebook, you just copy it here, copy all this command line, and then you have to paste it here. I'm not pasting it here because as soon as I paste it, it runs. I don't want to run it again, but what you need to do is you just paste it here and run it. So once you run this, you will find under the exported models, under my model, you will find these checkpoint saved models and pipeline.config. Everything gets copied here. So that's what this specific the export function or export method does, and it just exports our best model, which on which we will do the inference. So now we will do the inference cycle, which is again a one-liner, just a command line, and then you just have to give the test image file. So we'll see that in the next video.